Hi everyone, my name is Natalia Tomashenko. Welcome to our presentation of the First VoicePrivacy Attacker Challenge at ICASSP 2025. Speech data contains personal or sensitive information related to various speaker traits, including speaker identity, gender, age, accent, health status, to verbal content, non-verbal content, and acoustic environments. This raises serious privacy concerns and requires implementation of privacy-enhancing technologies to protect users' private information. Privacy preservation is formulated as a game between users and attackers. Users process their utterances with a privacy-enhancing system before sharing with others and performing some downstream tasks. Attackers access these processed utterances and wish to infer information about the users. The Voice Privacy Initiative was formed in 2020 with the aim to promote the development of privacy preservation tools for speech technology. So far, it has focused on improving voice anonymization systems and facilitating their comparison using common datasets, protocols, and evaluation metrics through a series of challenges. In particular, the system submitted to the Voice Privacy 2024 Challenge should remove the speaker identity at the utterance level and keep the linguistic and emotional content. To evaluate these anonymization systems, a semi-informed attack model was used. It will be described later. This attack model is the most realistic, but its implementation in the challenge was not the strongest possible. It can be improved, for example, by using more advanced ASV architectures, or taking into account spoken content similarities, or by other approaches. To ensure a fair and reliable privacy evaluation, it's important to find the strongest possible attacker against every anonymization system. For this reason, the current challenge edition takes the attacker's perspective and focuses on the development of the attacker systems against voice anonymization systems. We proposed in this challenge to attack the selected baseline of the best participants anonymization systems from the last anonymization challenge edition. Participants were required to develop attacker systems against voice anonymization systems selected among Voice Privacy 2024 Challenge baselines and systems developed by the participants. For each speaker, the attacker has access to one or more utterances, which are called enrollment utterances. The attacker system should output an ISV score for every given pair of trial utterance and enrollment speaker. To develop and evaluate the attacker system against a given voice anonymization system, participants had access to anonymized trial utterances, original and anonymized enrollment utterances, original and anonymized training data, and some other publicly available training resources for ACE. A description of voice anonymization systems and also the software of the systems when it is available. We use the equal error rate metric to evaluate the attacker's performance. So we provide training, development, and evaluation data, baseline attacker system, and evaluation scripts and metric. Participants apply the attacker systems to the provided anonymized data, submit ASV scores and equal error rate results. The attacker were ranked separately for each voice anonymization system. As a baseline, we consider the attacker system used in the Voice Privacy 2024 Challenge. It is a semi-informed attack model trained on anonymized training data. For a given trial utterance and enrollment speaker, the attacker computes the average speaker embedding of all anonymized enrollment utterances from that speaker and compares it to the speaker embedding of the anonymized trial utterance. The training data is the trained clean 360 subset of Libre speech original data and anonymized by 7 anonymization systems. In addition, participants were allowed to propose other training resources such as speech corpora and pre-trained models before the deadline. Based on these suggestions, the final list of training resources was published in the evaluation plan and presented on this slide. For development and evaluation, Libre speech, DevClean, and TestClean datasets were used, with the trial list from the Voice Privacy Challenge. In this table, you can see the number of trials in the development and evaluation datasets. Not all the training resources have been used by participants. Here you can see a summary of what was really used in the end, as well as additional undeclared resources. The voice anonymization systems to be attacked include free baseline systems from the Voice Privacy 2024 Challenge. Be free, based on using phonetic transcription, pitch and energy modification, and artificial pseudo-speaker embedding generation. B4, based on neural audio codec language modeling. And B5, based on using original pitch and VQ bottleneck feature extracted from an ISR model. The code for these systems is available and could be used by participants to develop their attack systems, for example, by generating additional training data. The anonymization systems to be attacked also include 4 selected systems developed by the Voice Privacy 2024 Challenge participants. For these 4 systems, and baseline attack model equal error rate was higher than 40%. The challenge attracted 41 registered teams from academia and industry in 12 countries. Among them, 11 teams submitted their results. In total, we received more than 50 submissions for 7 anonymization systems. This is the list of all teams who submitted the results. The columns are the team notation, team name, affiliation, countries, and team members. Yellow color highlights the top-ranked teams that were invited to submit papers to ICASSP. This is the summary of all the submitted systems. Green and gray colors correspond to the submitted systems. In particular, gray marks systems that may have some non-compliance with the challenge rules. Orange color highlights the systems with the best results. Here we can see the best equal error rate results for the best anonymization systems and for baselines. The black points show the equal error rate for the baseline attack models. The green and orange the best results for the teams. We can see that for all systems there is a huge decrease in equal error rate demonstrated by the best teams. Green color corresponds to the team who adopts the pre-trained ResNet34 ASV model using the LoRa technique on anonymized data and features computed by the WaveLM large model. This model configuration provides the best results for all anonymization systems except one, which is a hybrid admixture system. Orange color corresponds to the model trained on the fused datasets, which includes original and anonymized data, as well as using spec augment and LDA trained on anonymized data. This figure is related to the previous slide and shows the relative and absolute equal error rate reduction for the best attack systems with respect to the baseline. Here we can see the summary results for all the submitted attack systems. 2 teams, A22 and A42, submitted 2 results for some anonymization systems. There are many systems that outperform the baseline attackers. And here are the same results for all systems with the numbers for equal error rate values. Among the challenge submissions, we can notice several effective strategies that provide good results. These include using more advanced ASV model architectures such as ResNet34 and ZetaNet large models pre-trained on original data and adapted on the provided anonymized data, as well as training on the mixed original and anonymized data. The participants developed specialized attack models designed to each anonymization system, as well as more general models which work across multiple systems. Some teams also explored targeted approaches to exploit specific weaknesses in certain anonymization algorithms. Interestingly, attacks using only textual information achieve about 36% equal error rate, relieving the specificity of the Libre speech data. Most of the teams did not anonymize additional training or development data that was possible for some anonymization systems and use only the provided anonymized dataset. The Attacker Challenge participants have made a great progress and proposed various effective attacker systems. Many attackers significantly outperform the baseline attacker. The best ones reduce equal error rate by up to 80% absolute and up to 44% relative. The findings of the Attacker Challenge reveal that the privacy protection offered by the best anonymization systems from the Voice Privacy 2024 Challenge was overestimated. They also show that while attackers have made great progress in reducing the baseline equal error rates, the best anonymization methods still have provided moderate protection against speaker re-identification because equal error rate is larger than 25%. The challenge reveals the demand of new improved anonymization methods that are more robust to the new attacks. Another direction is related to more realistic privacy scenario and stronger attack models that, for example, can use metadata. One important scenario is longitudinal analysis. As attackers collect more voice samples from a victim over time, the ability to develop successful attacks may significantly increase. Another question is related to the development of general attacks that employ broad strategies that may work across multiple anonymization methods. Thank you very much for your attention.